morning. My name is Do-Gyun Kim from Seoul National University. Today I'm going to talk about the material hardening effect on the ultimate compressive strength behaviors. That is for the marine structural plate element. So let's get it started. So as you know, this is 10th anniversary of the Ships and Offshore Structures, the international conference. So very much appreciate for the Professor J.K. Park's continued support. So this is the content of the presentation, introduction, followed by the methodology and the result and the conclusions. So briefly introduce about the background and the objectives, including the scope. So as you can see here, the ships and offshore structures are subjected to the several types of the loadings: tension, compression, shear, lateral pressures, and etc. The plate element, as you can see here, these can be defined by the plate slantness ratio here, beta. So the left-hand side, B over T, represent the plate width or the breadth over the thickness. And here, A is the length of the plate. The right-hand side, inside of the root square, the material properties are defined, the yield strength and the elastic modulus. So that the beta, the plate slenderness ratio, can be defined by the material properties, right-hand side, and the left-hand side, the geometric properties. And once we define the beta, then we can calculate simulate the ultimate limit strength state, or the ultimate limit strength. We call the ULS, and that can be defined by the ultimate strength over the yield strength. So this is the material properties. I think this is the stress and the strain relationship. I think it is not necessarily to explain all the details. These can be obtained from the solid mechanics or the material information. So in here, we want to directly compare the effect of the hardening, as you can see here highlighted. In general, in our field, marine structural engineering field, we adopted the elasto-perfectly plastic model we call the EPP. So in order to define the hardening side, we need to understand about the ET and the sigma T values, as you can see here. This part is pretty much important for us. So current practices of the design standard for the hardening effect, which means that I want to directly compare our industry adopt the hardening effect or not. So the left-hand side shows the civil engineering industries. So they have the Euro code, as you can see here. They also adopt the EPP model, and they defined E over 10,000 or E over 100. And this is also the the true stress strain curve. But in our case, we have this is the harmonized CSL 2024. They have specified the the yield strength, that is miles to 24, 32, 36, and 40, and then they clearly specify the tensile strength, the range like that. But in that case, they have not mentioned about the ET, tangential, the slope, this value. So generally, we adopt the EPP model. And literature survey, as you can see here, there are several studies, and 1, 2, 3, Smith and the Pack and our group 2018, we have adopted the EPP model, and plate subjected to the actual compression. We have provided the proposed the design or the empirical formula. Recently, the Kadamati 2019, they have adopted the elastic plastic considering the hardening model, and they have provided this kind of empirical formula. But we can say that there is a lack of detailed comparative studies on the ULS difference between the material hardening and the EPP model. So this is our research target, the effect of the ET and the sigma T. Of course, we will consider the different types of the loading conditions and different the betas and etc. So I will elaborate on that soon. So we have mentioned about the limitation, lack of the ULS studies and the absence of the guidelines. We can improve on that. So that this is our, research objectives. So we'd like to analyze the effect of the material hardening on the ULS behavior. And we want to provide the useful user guidelines for the material hardening model. So it is almost not, it is always challenging to cover all the cases so that this will be our scope. So loading conditions, we have adopted longitudinal compression and the transverse compression. And the loading condition 3 is longitudinal compression with the lateral pressure. And simply supported boundary condition for all edges are adopted for the plate. Initial imperfections that can be split into two: initial deflections and the welding residual stress values. Those two, we adopted average values. You can also, refer to the Smiths and other values. So material properties, we adopted the mild steel 24 and high 10 32, 36, and 40, and EPP model and the hardening models are adopted. So scenarios, I will elaborate on this soon. So this is the main body. I will talk about the methodology and the research. So you can see here, we will follow this step. So step 1, we will collect the target structures. In this study, our target is the flat plate. And we need to define the target structural characteristics, geometric and material models, as I mentioned earlier. And we will finalize the selection of the scenarios: initial imperfection, loading conditions, boundary condition, and etc. Followed by the calculation of the ULS. In this study, we will adopt the nonlinear finite element analysis, FEA, and the collected ULS values will be processed, and then finally we will provide the useful design, the formula. So step 1, 2, 3, this is selected scenarios, geometric properties. You can see that the length and the breadth and the thickness, we have changed 6 types so that we are gonna have 6 betas. And the material properties, we have 4 different yield strengths, and the elastic modulus and the Poisson's ratios are exactly the same. And we will directly compare those two effects. As I mentioned earlier, loading conditions, number 1 and 2 and 3. And in the case of lateral pressure, we adopted the 0 lateral pressure and the 5 meter, 10 meter, and 15 and 20 meter hydrostatic pressure considered. So let's move on. So this is the summary. Material properties, as I mentioned earlier, this is the hardening model and harmonized CSL. They have specified about the sigma T. So ranged by the 400 to 520 for the mild steel case. So we try to split it into 3, 400, 520, and 460. And for the study purpose, we have added one more, much more higher values. So we do the same job for the 32, 36, and the 40 materials. You can see these selected ultimate tensile strength values. And number 2, just now we have confirmed the ultimate tensile strength. The next one is the tangential modulus. ET should also be confirmed. So in our study, we have selected 3, and you can see here, the left-hand side, the PAC at all 2017 Ships and Offshore Structural Journal. They have tested several things on the material coupon test. And based on these values, we try to plot the slopes like here. So the value is E over 50, E over 100, and E over 250. So we define these, and the final cases are elaborated here, nearly 1,700 cases. And you can see all the detailed, the scenario cases, 4 different yield strengths, and ultimate tensile strength 4, and the ET value 3, and the plate thickness 6, and the loading conditions in total like that. So that we have like 1,700 cases. Let's move on. So step 4 and 5, we need to calculate the target data. So loading conditions are different, and material curve, these are already defined. And then we will apply the initial imperfections and loading conditions 1, 2, 3 here. And finally, we will extract the ULS values like that. So step 6, from here, I will talk about the obtained outcome and the investigations. So we want to talk about the ultimate tensile strength value first on the ULS for all loading conditions. So as you can see here, we selected APP model and sigma T 1, 2, 3, and 4 for all materials. But this is one of the typical examples, but the others are nearly similar. So as you can see here, there was no significant contributions to the ULS behaviors. Even we changed the ET 1, 2, 3, 4, sigma T values, there was no changes overall. Even for the load shortening curves are nearly similar. So constant result, even we changed the different material, tangential moduli, and loading conditions, and the thickness or the beta, it was no changes. So this effect is not significant. That was one finding. Followed by the tangential modulus, ET effect on the ULS, and the number one, subjected to the longitudinal compression cases. As you can see here, we selected EPP model and ET 1, 2, and 3, and then as beta increased, we checked the ULS values. You can see here there is some changes, and this is the outcome. So maximum nearly 4% of the ULS was detected. Minimum was nearly 1%. And followed by the transverse compression cases. The other things are nearly same. And the maximum was 2.0 and the minimum was nearly 0.3. It was almost nothing. And the pressure case, this is the last one, longitudinal compression with the lateral pressure cases, this was significant. As you can see here, we changed the plate slenderness ratio, which means that the beta increase means the plate is getting thinner, getting slender, so that ULS the changes are increased by as the lateral pressure increased. So the maximum value was nearly 15%. And this will be the summary. Case 1, 2, and 3, as I mentioned earlier. So the maximum values were highlighted here, like nearly 4 and the 2, and the pressure cases nearly 15%. So for more detailed analysis, we check the stress distribution. This is case 1, and 2 is transverse compression. 3 is axial compression with lateral pressure. So you can see here, this is one of the important figure. So case 1 first, this is EPP model, and the right-hand side is the hardening model, for example. So even we apply the axial compression, the left-hand side, this is the case stress distribution, and the right-hand side stress distribution, the contour is nearly similar, but the color changes, which means that it goes up here. So case 2 case, left and the right-hand side, the contour is nearly similar, color is also nearly the similar, which means that even we adopt the hardening model, the case 2 case, it is not available to utilize this hardening curve enoughly. You know what I'm saying? So case 2 is worst, case 1 move forward, and case 3 is the best case to utilize the hardening model. So that you can see here, you can see the red and the orange, and the more colors have been used in the pressure cases, which means that the membrane tension effect is directly affected in case 3, subjected to the lateral pressure. So that in the hardening model, the stress reaches the hardening range only in certain limited regions for the case 2. And the 1, an area reaching the hardening range, the rate of the ULS increase that can be seen that case 3 and 1 and 2. So the conclusion is the no area reaches the ultimate tensile strength. At the same time, the values has no significant effect on the ULS or compression behavior. But pressure cases, we can see that the hardening model will provide some, useful, insight. So Finally, based on the obtained nearly 1,700 the ULS data set, we tried to develop the empirical formula. So formula, the function of the plate slenderness ratio, and you can see here the empirical formula shape we extract from the Kim et al., our TIMS 2018 outcome. And we plotted based on the ET value. And in this equation, we have C1 to 4, the sub-formula that includes the K value in here. ET is elastic modulus over K. So K value is 50 to 250. And as you can see here, all curves looks good agreement with the data set. So this is the outcome. And the transverse compression case, we do the same job. We could be able to obtain the nearly similar and a good outcome. In the case of pressure cases, we are still doing the data processing, and soon we could be able to provide the empirical formulas. This is the summary for the longitudinal compression and the transverse compression here. So finally, conclusion here. So limitation and the objectives. So this is the outcome. Sigma t, that value does not contribute to the increment in the ULS values. And number 2 is important. The tangential modulus ET was directly proportional to the increment in ULS. And the hardening effect is most pronounced in the order of longitudinal compression with the lateral pressure cases due to the membrane, the tension effect, and the longitudinal compression and the transverse compression cases. And we successfully provided the empirical formulas in predicting the ultimate limit state of the plate subjected to the compression cases, including the material hardening effect. But at the same time, we can think that the further study should be conducted to consider the shear and the combined loading cases. At the same time, we also think about the repeated load cases, including the fatigue limit status. Or we can also consider the ALS, the accidental limit state cases. So that's all for me today. Thank you very much for your kind attention.